Alright, this video we're going to look at direct variation. I'm going to do two examples. One's going to be a simple example just to kind of understand, to help you understand what we need to find when we're doing direct variation. And then the second example will be a word problem. Alright, so here on direct variation, the following statements are equivalent. Y varies directly as X. Y is directly proportional to X. Okay, so in the problem, they may say Y varies directly, or they may say Y is directly proportional. That means the same thing. Okay, so if this is what they're telling you, then the equation you'll use is Y equals K times X, where K is some non-zero constant. And K is the constant of variation or the constant of proportionality. Alright, so whenever they say Y varies directly as X, you know this will be your equation. Y equals K times X. Alright, so let's take a look at an example. Alright, so here it says find a mathematical model representing this statement. It says A varies directly as R squared. Okay, and they tell us A is equal to 9 pi when R equals 3. So what they're doing is they're telling us the form of the equation, and then they're giving us information so we can figure out what K is, our constant. Okay, all right, so first let's go ahead and get our equation. So A varies directly as R squared. So that means A is equal to K times R squared. All right. Now they're giving us the information A is equal to 9 pi and R is equal to 3. So the 9 pi we're going to plug in for A, and the 3 we're going to plug in for R. All right. So we're going to replace A with 9 pi, and we're going to replace R with 3. So that equals K times 3 squared. And so that gives us 9 pi is equal to 9K. And then if we solve for K, we're going to get K equals pi. Okay. All right. So now we have A is equal to pi times R squared. All we did is we took the value we found for K based on this information they gave us, and we plugged it in for K. Okay, the pi we plugged in for K. So this is our mathematical model, and you can see it's the area of a circle. All right, so now let's look at a word problem. All right, it says the diameter d of the largest particle that can be moved by a stream varies directly as the square of the velocity v of the stream. Okay, so let's go ahead and write our equation down. So it says the diameter d varies directly as the square of the velocity. So that's k times v squared. All right, so now they're giving us information. A stream with a velocity of 1/4 mile per hour can move coarse sand particles about 0.02. Okay, so this is our V, and this is D, the 0.02. So what they're doing is they're giving us this information to plug into here so we can find K. All right, so let's plug that in and find K. So we have 0.02 is equal to K times, now this is 1/4 squared. Okay, 1/4 squared. All right, so now let's find K. We need to solve for K. All right, so we got 0.02 equals, and then the 1/4 squared, I'm going to go ahead and punch that into my calculator. and that is 0.0625 K. And then I'll divide by 0.0625, and so I'm going to get K is equal to 0.32. So that gives me my equation. D is equal to K, and K is 0.32 times V squared. Alright, so now that we have our equation, now they're asking us to approximate the velocity required to carry the particles 0.2 inches in diameter. Okay, so they're saying, okay, if the diameter is 0.12, okay, they want to know what V is. What's the velocity? Okay, everybody see that? All right, so now let's solve for V. So I'll divide by 0.32, and so I get V squared, and we'll punch this into our calculator, and that is 0.3, let me write that better, 0.375, and so V is the square root of 0.375, and then if we put that in our calculator, I'm going to round it to 3 decimals, 0.612, and we are in miles per hour. So that's miles per hour. Okay. So that's the velocity required to move a particle with this diameter. Okay. Down in a stream, to be moved by a stream. Alright, so I hope this helped. Check out my other videos. Give me a like and subscribe, and thanks for watching.